Now look at this interesting integral. And of course, we do the inside first, the inside square root, which is equal to 1 sine square x plus cosine square x, right, plus 2 sine x cosine x and dx, right? Then the inside the square root becomes, this is 100 pi, is equal to 0 to 100 pi. Inside will be sine x plus cosine x square. Now the square root and the square cancel out, so inside must be positive. So it becomes the absolute value of the sine x plus cosine x dx. Very good. And this one is equal to 0 to 100 pi. This is absolute value of root 2 times sine x plus quarter pi. Yeah, that's obvious. Now, all right, this function sine x plus quarter pi is a function of sine x shift to quarter pi, right? Yeah, and this function, the period of a sine function positive is a is a pi, right? This is sine x absolute value, right? It's it becomes this. Right? It's pi, 2 pi, right? Because it's a negative pi and flip over to the positive. So the period of this function is pi. And a property of periodic functions says that the integral over any single interval of a length equal to its property is identical regardless the phase of shift. So based on that property, this one is the same as the period of this is period of pi, right? It becomes root 2 times 100. So, and the sine x dx. That's right. Because the property says that the interval over any single interval of length equal to its period of is identical regardless the shift. So regardless of shift. So this function, the period is pi. Okay, so that one makes it easy. Root 2 times 100. And this is a negative cosine x from 0 to pi. So this is a 1 and a 1, and it becomes a 2. So it becomes root 2 times 200 pi. No, what am I doing? This is a 2, right? So it becomes a root 2 times a 200. That's it. So this is my result. Okay, good.